Hey guys, so our first lesson here in Chapter 1 is just going to go over the basic terminology of expressions. Okay, so our goal for today is to be able to write verbal expressions as algebraic expressions. Okay, so to see a sentence and be able to turn it into something, some type of math or algebraic expression, right? And then vice versa. So we'll start with a variable. A variable is just a letter that's used to represent one or more numbers, okay? It doesn't necessarily even have to be a letter. It could really be any symbol. Usually you'll see letters. So N, C, X, X down here. All of those would be examples of variables. And as you get to higher levels of math, you'll be introduced to using a lot of letters with the Greek alphabet and even other symbols to represent variables, okay? An algebraic expression is just any statement that includes at least one variable, okay? So it's a group of numbers, operations, and variables, okay? Within an algebraic expression, you're going to see a couple different things, right? So I'm going to talk about terms. Terms are quantities that are added. And remember that adding and subtracting are really the same thing. So any quantities that are added or subtracted work there, okay? So for example, 6 is one term and C is another term. 2x is a term, 8 is a term, okay? 5 and n are not added together or subtracted, so that's just one term altogether. They're not individual terms, okay? And a factor, okay? A factor are two quantities that are multiplied together, okay? So in this case, 5, we have 5 times n, so 5 and n would be factors. Okay, same idea for 2 and x. 2 and x would both be factors because they're multiplied together right here. Okay, these couple examples are just going to quickly go over some common algebraic expressions. Okay, so this first one is all the exact same thing. It represents 5 times n. Okay, so you might see one of the numbers or one of the factors in parentheses. Right, so if you see a number or a variable, and then parentheses and another number or variable, then you assume that you're multiplying between those two. This dot also represents a time symbol. You might not even have anything in between them, so 5n there is 5 times n. And then, of course, we could also do 5 times n. All of that would work. Okay. For 6 plus c, okay, 6 plus c, we've got two different terms here. 6 is one term, and c is another term, okay, because they are added together. And lastly, 2x minus 8. So for 2x minus 8, we've got 2 and x, right? That's one term with two different factors. 2 is a factor, and x is a factor. And we have another term here, the 8, okay? So that's pretty much how algebraic expressions work. Now, power is an expression that includes a base and an exponent, okay? And let me show you what each of those are. So we have the base is the x, okay, the big number on the bottom, and the exponent is the number in the superscript up top, this little number up on top, so the n there. So x to the nth power, that's how you would say x to the n right there. Okay, so a couple examples of that. You've heard of some of these. 4 to the third is 4 cubed. You say that as 4 cubed, and what that means is it means 4 times 4 times 4. So it's 3 4s, 1, 2, 3 4s multiplied together. So the answer to that is 4 times 4 is 16, and 16 times 4 is 64. Okay? Now x to the first, anything to the first power is just whatever the base is. Okay, so x to the first power equals x, and 1/3 to the fourth power. So if you have a fraction, okay, you actually just write that fraction times itself that many times. So we've got the fourth power, so we've got 1, 2, 3, 4. 1/3 all multiplied together. Remember, when we multiply fractions, we just multiply all the tops together and multiply all the bottoms together. So we've got 1 times 1 times 1 times 1 equals 1. And the bottom, we've got 3 times 3 equals 9. 3 times 3 equals 9, so these become 9. These become 9. When you multiply 9 times 9 together, you get 81. So the answer to 1/3 to the fourth power would be 1/81st. Right, this table next is just how to translate verbal phrases into algebraic expressions. Okay, so if you take a look here, on the left side I've got the operations, the 4 operations that we know: addition, subtraction, multiplication, and division. Okay, right after that I list all the words that are key that make you kind of trigger you to thinking about that certain operation. Okay, so take a look at those and get yourself re-familiar with them. Because when you see those words in these verbal phrases in the next section, you will know pretty much which of the 4 operations we're talking about. Okay? And into some examples. Okay, so now what we're going to do is we're going to write a verbal expression for each algebraic expression. So I'm going to look at the algebraic expression that's given, and I'm going to write it in words. Okay, so I've got 16u squared minus 3. Okay, there's a lot of different ways you can write this. Right? Remember, this is a subtraction problem, so we're going to be using one of these. Okay, so what I'll do is I'm going to use less than, because that's a hard one to use. Okay, so for less than, if I want to say this, it's 3 less than whatever I have in the first term. Okay, so the way that I would write this, I'd write 3 less than 16 times the square of u. Okay, so 3 less than 16 times the square of u is the same as 16u squared minus 3. All right, and number 2, I've got 1/2 times a plus 6b over 7. Okay, so there's a couple different things that we could do. Obviously, for these verbal expressions, there's lots of different ways you could write them. So if you come up with another one, it may also be right. Right, first thing we need to do is work with the 1/2 times the a. Right, so pick one of the multiplication ones. All right, I'm going to use, I'll use of. Okay, so one way to start here is we could write 1/2 of a. Okay, and then we could pick any of the addition ones because we're going to add this. So sum plus more than increased by. We could just do increased by by 6 times b divided by 7. Okay, so 1/2 of a increased by 6 times b divided by 7, and that's the same as our algebraic expression right here. Okay, let's go to a couple more examples. Alright, so we're going to translate the verbal phrase now into an expression. For this one, for the verbal phrase into an expression one, there's really only one correct answer. Okay, so we've got 1/3 of a quantity. So 1/3 of, remember that of means times, the quantity of, so quantity means two different things together. Right? Quantity usually it symbolizes getting a parentheses. Right? So that's something you want to probably jot down. 4 plus a number n. Okay, so 1/3 times the quantity, 4 plus n. We have 12 decreased by, remember if you look up in your table, it's subtraction, decreased by the cube of a number x. So x cubed. And the last one here, the quotient of the square of a number w, so w squared. Remember, quotient means divided, so you could use this sign or you could do a fraction line, divided by 5. So this would be one correct answer, or w squared over 5 is another correct answer, because the division sign and a fraction bar really mean the same thing. They both mean divided by. All right, we're going to evaluate a couple expressions with exponents. Okay, so we're going to do n to the 5th when n equals 3. So we've got 3, n is 3, so 3 to the 5th equals 3 times 3 times 3 times 3 times 3. Okay, remember you're just multiplying all these together. 3 times 3 is 9, 3 times 3 is 9, okay, and then times 3. Okay, so we make this a little bit easier. We know that 9 times 9 is 81, so this is the same as 81 times 3. And lastly, we do 81 times 3, and you get 243. Okay, and d squared when d equals 9 over 5, or 9/5, so we got 9/5 squared equals, remember it's 9 fifths times 9 fifths. So we've got to multiply the top together, 81, and multiply the bottom together. 5 times 5 is 25, and that's the answer. Now, number 4, you're ordering a skateboard and a helmet from an online store. The total weight of the two items can be represented as by S plus H, where S is the weight of the skateboard, H is the weight of the helmet. We find the total weight of if the helmet weighs 1.3 kilograms, so 1.3, remember, is H, and the skateboard weighs 5.4. Okay, so we've got 5.4 kilograms plus 1.3 kilograms. We can add these together. We're going to get 6.7 kilograms is the total. And lastly, the most difficult one, we have the length of a building. So we've got a building here. Boop. Okay, so the building, the length of it is 20 feet more than its width. Okay, so the width, let's just say the width is right here. The length over here is 20 feet more than the width. Okay, so the L is equal to 20 plus W, right? 20 more than W. Okay, so the length is 20 plus W. We're going to write an expression for the length of the building. Okay? So the length of the building, we already wrote it, the length equals W plus 20, because 20 feet more than the width. And that's it for this section.